Good morning, everybody. Good afternoon. Good day. How are you all doing? Doing great this morning? I hope so. It's bright and blue outside. I'm all excited to discuss on a new topic. So, without further ado, let me get started. So, we are going to talk about experiments in statistics. Why we need to do experiments? Suppose, think of a medical company manufacturing a new drug, wants to test the effectiveness of the new drug as opposed to the existing drug. Then they have to conduct a statistical experiment in which they will compare the new drug with the existing drug. Is the new drug better than the existing drug in controlling or curing the disease that they're interested in? That is the question. And they will recruit volunteers to participate in these trials or in these experiments, and data will be collected, analyzed, and conclusion will be drawn, all using statistical techniques. That's why we need experiments, okay, in statistics. So, what is an experiment really? Experiment is a study, as they write, in which one or more explanatory variables are manipulated in order to observe the effect on a response variable. In the example that I just now gave, uh, experiment was to test the effectiveness of the new drug as compared to the existing drug. So my explanatory variable, what explains the results, is the new drug. We are comparing the existing drug with the new drug. So that's my explanatory variable. Experiment is I'm taking, controlling some factors. Like if I divide the participants into groups, one group takes the existing drug, the other group takes the new drug. I'm controlling those factors. Therefore, I'm running an experiment. So explanatory variable, these variables that are values that are controlled by the experimenter. Explanatory variables are also called factors. In my example, very simple, the explanatory variable is the old drug compared to the new drug. So the drug is the explanatory variable. The response variable, of course, in my situation, response is how the patients are responding to the new drug as compared to the existing drug. Okay. And experimental condition, we might control, for example, the room temperature. Okay. That may be my condition. Okay. Experimental conditions are also called treatments. Or in my example, I may control the level of the drug. The new drug I want to give in certain milligrams, not a whole lot. Or I may have couple of levels of that drug, say 10 milligram and 15 milligram. Which one is more effective, the new drug? In general, you can identify the explanatory variables and the response variable easily if you can describe the purpose of the experiment in the following terms. The purpose is to assess the effect of the new drug on the curing of the disease. So, explanatory variable, new drug, response variable, whether it cures the disease or not. The goal is to design an experiment. Again, an experiment is a series of trials that we run under controlled condition that will allow you to determine the effects of the explanatory variable on the chosen response variable. Again, please remember my explanatory variable is the new drug. And I'm comparing the new drug with the old drug and how it cures the disease. To do this, you must take into consideration any extraneous variables that also not of interest in the current study might also affect the response variable. Extraneous, as the name suggests, is extra, is outside the purpose of the study. A variable that is not one of the experimental explanatory variables in the study but is thought to affect the response of the variable. For example, in the drug test, diet of the patient may be an extraneous variable. What type of diet is the patient taking? For example, okay. So that's an extraneous variable outside the scope of the experiment, but it will still affect the quality of the results. With a partner, did be prepared to share your answer. If the room temperature experiment was carried out as described above, what is an example of extraneous variables? I believe the experiment they're talking about here is where two sections of the same course are being are going through a test, same test, but in two different rooms, two different sections, and the two different conditions, temperatures in the room, okay, and maybe time of the day, okay. Answer: an example of extraneous variable in the room temperature experiment is the time of the day. So two rooms maintain the two different temperatures, but also they're conducting the test, same test in the two rooms, two sections, but at different times of the day. So what they're saying here, time is an extraneous variable. That is a variable, a factor outside the scope of the experiment, but it might affect the results. A well designed experiment addresses extraneous variables through strategies such as random assignment. Again, the name random implies people who are participating in this study are selected randomly without any preference, without any control. Okay. Random extra assignment, direct control, and blocking. These methods enhance the experimental reliability by minimizing unwanted influences on study outcomes. So if you randomly assign people into the two groups or two rooms, okay, one at room temperature, other at slightly elevated temperature, okay, you randomly assign the participants, okay. So what is the purpose of doing that? The purpose of randomly assigning volunteers into the groups is to remove any unwanted influence on the outcomes. Okay, so you do not want any other extraneous influence to affect the results. Researchers can directly control some extraneous variables. The effect of some extraneous variable can be taken into account by a process known as blocking. Extraneous variables that are addressed through blocking are called blocking variables. Remember, in the two rooms at two different temperatures, same test conducted, one in the afternoon, one in the morning. Here, time of the day is an extraneous variable. Okay. An investigator using blocking creates groups called blocks that are similar with respect to blocking variables. Then all treatments are tried in each block. Okay. Each block means, as I told you, the extraneous variable in the previous example was the time of the day, one in the morning, one in the afternoon. Okay, and then you have two different rooms at two different temperatures. Well, we can check the effect of the temperature on the performance of the students, but to remove the extraneous variable, which is the time of the day, we can conduct this experiment or the test can be done on this with the students at the same time of the day. So the time which is an outside variable is removed. Okay. Two variables are confounded if their effects on the response variable cannot be distinguished from one another. Confounded means they're bounded together, confounding or confusing the results. Two variables mean two factors. We cannot separate the effect of these variables. then they are said to be confounded or confused or confusing the results together. Okay. With a partner, discuss the following. Be prepared to share your insights with the class. If all of the 65-degree sections were taught at 10 a.m. and all of the 75-degree sections were taught at 3 p.m., what could be the would time of the day be confounded with the temperature? Yeah, sure. Because one of them is at morning in the morning class, the other is the afternoon class. So it's better to remove that confounding variable by conducting both the sections, one at 65 degree, another at 75-degree temperature. Do it at the same time of the day. Okay. Confounding variables, extraneous variables confounded with explanatory variables impede clear conclusions. Both direct control and blocking prevent confounding of controlled and blocking variables. So, what are they saying here? Confounding variables, we saw temperature, time of the day is a confounding variable. And if we do not remove that confounding variable, what will happen? That will influence the result. So we will not know for sure whether the temperatures in the two different rooms made a difference in the results. It could be that the time of the day is also a factor. So time is confounding the result, which is the performance of the students in the test. But at the same time, um, time is confounding the result. At the same time, there are two different temperatures. So which is the real culprit? Which is the real controlling variable? Is it temperature in the room or the time of the day? We remove the confounding variable, which is the time of the day. Do the test or the same time of the day, maybe in the afternoon, then time is removed as a confounding variable which may have which could have influenced the result if we did not remove it. Both direct control and blocking prevent. So direct, what I talked about right now is direct control, where I conduct both the test at two different temperatures, two different rooms, but at the same time, instead of doing the morning, do everything in the afternoon. So directly I'm controlling the confounding variable. Another way to control this is blocking. Blocking creates groups that filter out the effects of extraneous variables. Okay. Distinguish random assignment. Okay. So what is blocking? They're going to discuss more about it later on, but at this point you can think about blocking where the blocks are similar inside. Similar, each block is similar. For example, suppose I'm trying to teach the or trying to determine the effect of a new method of reading skills to primary school students. To Okay, and they're from grade 1 through grade 4. The best way to do this would be to compare the new method of teaching of reading skills to the old method of teaching skills is to divide the entire student body into uh, grades. The grades then become the blocks: grade 1, grade 2, grade 3, and grade 4. Do not mix a grade 1 with a grade 4. That is, do not constitute or do not form an experimental group which has some grade 1 students and some grade 4 students. Why? Because grade 4 students have better reading skills already. So how will you find out the effect of the new reading tools that you're teaching them? Because you have mixed up grade 4 with grade 1. Okay, that's not good because grade 4s will skew the results because they already have good reading skills. On top of them, you're giving them or teaching them a new method of reading that will improve their score. So the best way to do it is to create blocks or groups of students. Block 1, grade 1, block 2, grade 2, block 3, grade 3, block 4, grade 4. Then inside each block, compare the existing method with the new method of teaching reading. Okay. Distinguishing random assignment different from random selection of subjects. Ideal scenario having both random selection and random assignments of students to the experimental condition. Okay, such as this would allow conclusions for broader generalizability. So what we are talking about is not only we randomly select volunteers to participate in the study, but we randomly assign the volunteers into maybe two experimental groups, one with the existing method, the other with the newer method. Okay. Random assignment either of the subjects to treatments. In my example, random assignment of students to the two methods. One is an existing method of teaching, the other is a new method of teaching. This is subjects to the treatments. Okay. Replication is the design strategy of making multiple observations for each experimental conditions. Just one observation in each experimental condition is no good. We have to do it more times, repeat it. Okay. So random assignment of subjects to treatments, which we just discussed, or treatments to trials to ensure that experiment does not statistically favor one experimental condition. We also talked about blocking using extraneous variables to create blocks. In my example, it was grade 1, grade 2, grade 3, grade 4. These are separate blocks in which we are going to divide each block into two groups. One will get the current method of teaching, the other the new method of teaching. Direct control, the example we talked about, directly control the extraneous variable of time of the day. Conduct the experiment on two different groups at the same time of the day. Remove time as an extraneous variable. Replication, we have to repeat. Treatments to experimental conditions, such as we already talked about it, two different temperatures in two different rooms, same sections of the same course, but at two different rooms, two different temperatures. So temperature is the treatment. Okay. The treatments together are plausible values of the explanatory variable, because remember, temperature, we are looking at the effect of temperature, which is the explanatory variable, on the response variable, which is test score, under two different conditions. Okay. Extraneous variables are variables other than explanatory variables. We already talked about it. One is the time of the day during which the two tests were done in two different rooms at two different temperatures. We directly controlled it by removing that extraneous variable, conducting both the test in both the sections at the same time of the day, or we can use blocking. Okay. uh, Extraneous variables that are not incorporated into the experimental design through direct control or blocking. What do you do? Strategy in that case is randomly assign the students or the participants or the volunteers in the study in the two experimental groups. So all this time we are talking about random assignment. We are also talking about blocking. We are also talking about direct control of extraneous variable. So you are guessing how will I apply all these concepts that I have learned? Well, you have to think about some factors or variables that you are studying that is affecting the result of another variable. Okay, that is the response variable. And your explanatory variable is such as the room temperature, for example. How is it affecting the explanatory variable, which is test score? But how will you apply all these concepts? That might be um, big question for you, that might be confusing you. Well, here you go. You have come to the correct presentation. I'm going to break it down for you how I'm going to apply all these concepts so that I can make some statistical conclusions, valid conclusions based from my studies. So, how the next part is how to apply the concepts that we just learned into real life. That is the question, okay? Application in real life. So, please do not quit. Please wait till the end of the video. I'm making a request. And please, if you like this video, give me a thumbs up. and please subscribe to my channel. So moving forward, okay. Note on random assignment creates. So how will you randomly assign people? Well, one way is to create slips, okay, with subject names or unique numbers mixed in a container. This is the old fashioned way where you are writing the number. Suppose there are 50 participants in your study. In small slips of paper, write the numbers from 1 to 50, fold them up, put them in a big container, shake up the container, and then randomly, like lottery, draw the numbers. Okay. Repeat until all the groups are assigned. Assign each subject a unique number. This is the second method. 1 to n, where n represents the total number of subjects. Use random number generator. This is the way we generate simple random sample using computer. What do we do? I have discussed this before in the previous chapter. What we do is, suppose I want to select a simple random sample of 30 students from my campus, which has like say 10,000 students. What do? I approach the registrar. Please give me a list of students arranged by last name alphabetically, starting with A as in apple, going to Z as in zebra. Okay, based on last name. So I have a list of 10,000 students, 10,000 numbers. Then I will ask the computer program, please generate me a list of 30 numbers from between 1 and 10,000. Okay. Why I limit to 30? Because I want to select a sample of size 30. So for example, the random number generator, the software will come up with a list of numbers, 30 numbers starting with 601. What does it mean? The student whose number is 601 will get selected. Suppose the next number is 520. Student whose number is 520 will get selected, and so forth. This is the way we generate a simple random sample of size 30. Why random? Because there is no preference shown to any student. Why simple? Because the process is simple. Sometimes a random mechanism is used to determine the which treatment will be assigned to a particular subjects. Okay, friend, thank you. So here is an example. Remember, I told you how do I apply this in practice? So here is an example where they've applied this kind of technique in practice. So the morning effect, the influence of time of the day on unilateral behavior, on unethical behavior, describes 4 studies investigated whether people are more ethical in the morning than in the afternoon. In one of the studies, experiment one, volunteers selected either a morning or an afternoon sessions. During the sessions, participants were paid to complete a task that presented opportunities to increase the amount earned by purposely providing incorrect responses. The researchers concluded that participants in the afternoon sessions cheated in order to increase the amount they would be paid significantly more often than those in the morning. See, you earn more if you answered the questions incorrectly. You probably noticed that the researchers did not randomly assign participants to the two experimental conclusions, morning time and afternoon time. This flaw was noted in the paper. Okay. To overcome limitations, 2 additional experiments were conducted. In one, 70 volunteers were randomly assigned to the morning or afternoon sessions, tasked with identifying pairs totaling 10 from the sets of 12 three-digit numbers. Afternoon participants reported significantly more accurate findings, suggesting more honesty in the afternoon participants with significantly more accurate findings, suggesting more honesty in the morning. Okay. The important point in this study is that the volunteers that were selected, they were randomly assigned either to the morning session or to the afternoon sessions. So randomly assigning um, people who are participating into the two experimental condition, morning session and the afternoon session. And they noticed that the people in the morning were more honest. Okay, so this is basically a diagram called a flow diagram, how the information flows from the left to the right. Left is the people who are participating in the study, experimental units, and then you are randomly assigning them to two groups. One is treatment A, treatment B, such as the two different room temperatures. Okay, and you measure the effect of the treatment response variable on the or measure the effect of the treatments, two treatments, experimental conditions on the response variable at the end. So starting from the left, going to the right. First select the volunteer, experimental conditions, two different experimental conditions, treatment A and treatment B. Do they influence the final results? Response variable. That is the question. It is another with people would adding climate impact labels to food options on a fast food restaurant menu have an effect on what people order at the restaurant? This is the question investigated by the authors on the paper. An experiment was conducted in which participants were shown a fast food menu and asked to select an item that they would like to order for dinner. The participants were randomly assigned to one of the three groups. There were a total of 5,049 participants, 1,666 to Group 1, 1,667 to Group 2, and 1,716 to Group 3. In the study, the first group received menus without climate impact labels. So that's why there are three groups. One of the first group menus, the food they got, no climate impact labels. The second group had green labels on environmentally sustainable choices, while the third group's red labels signaled high climate impact. Researchers noted participants' red meat menu item choices, providing insights into the influence of climate impact labeling on food selection. What is the explanatory variable? What kind of labels they're getting? What is the experimental conditions? What is the response variable? Okay, so here is a flow diagram. Okay, data analysis revealed fewer red meat orders when participants received menus with climate impact labels. Okay, group 1, no labels. Okay, so as you can see, three branches coming out from the left block. One of them was group 1, and volunteers were randomly assigned to that group. They got no labels showing the effect on the climate effect on the foods they're having. No labels. Okay, and record what food they chose. Group 2, they were given low impact labels. Again, record what food they ordered. And group 3, they got high impact labels. Okay. And what did they find out? Researchers assert that incorporating such labels, especially with heightened climate impact, that is group 3, uh, people were more judicious in selecting foods that were sustainable to the environment. The basic structure of this experiment, so three conditions based on the labels that people received in their food choices, and based on that information, what food did they select at the end, and what was the impact on the climate. So that was what was measured. This type of diagram provides a nice summary of the experiment, but notice several important characteristics of the experiment are not captured in the diagram. For example, diagram does not show how participants were selected, how were they randomly selected, or if any extraneous variables were directly controlled. This means that while a diagram of an experiment may be a useful tool, it cannot be used in describe an experimental design. Experimental designs in which experimental units are assigned at random to treatments, or in which treatments are assigned at random to trials, are called completely randomized design. This is what we talked about in the previous slide. For example, they They randomly assigned the people who wanted to participate in the study into three different groups. One group got and no labels, second group got green labels, and the third group got red labels. Okay, so this was a completely randomized design because the volunteers were randomly placed in these groups. When blocking is used, the design is called randomized block design. What is a block? Remember that experiment I talked about? I want to find out the effect of a new teaching reading skill teaching method to grade 1 through grade 4 students. I divided the students into blocks: grade 1, block 1, grade 2, block 2, grade 3, block 3, grade 4, block 4. Why did I do it that way? Why did I divide them into blocks? So that grade 4 students do not get mixed with grade 1 and skew the results. When blocking is incorporated in an experiment, the random assignment to treatments occur after the blocks have been formed and is done separate. So in each block, then you will randomly put students into two different groups. One got the new method of teaching, the other get the old method of teaching. Before proceeding with an experiment, you should be able to give satisfactory answer to each of the following. This is very important. So what is the research question? That data from the experiment will be used to answer. What is the response variable? What are you going to measure? How will the values of the response variable be determined? What are the variables that explain the results? For each explanatory variable, how many different values are there? Okay, and so forth. Treatments, extraneous variable we talked about, time of the day, for example. Okay. How does the design incorporate a random assignment? One of the methods we talked about is a random number generator, for example. Another method is to write the numbers in a slips of paper, put it in a container and shake it up and then randomly select. All of this we are doing is so that there is no bias in our selection process. Okay. So I stop here today. If you have any question or comment, please do not hesitate to ask me a question. If you like this video, please give me a thumbs up. I really appreciate that. And you have any question, let me know. Also, I'm very curious to find out where are you watching my videos from. Please let me know that. I really appreciate that. And in case you have any question, you can jot it down and write it there, and I'll respond to each of your questions. And please, if you like this video, share with your friends and give me a thumbs up. And please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And at the same time, please do not forget to click on the notify bell, because every time I'll upload a new video, you will be notified. And please do not forget to watch me tomorrow when I'll be back with another interesting video just for you. And I really thank you for going so far in the video, taking time and listening to me. I hope you understood something. If you have any question, please write me a note. I'll get back to you. And I look forward to see you tomorrow. Thanks for watching. Take care. Have a nice day. See you next time.